Sometimes we see exponents and they're actually multiplied together, or they're added together, or they're subtracted from each other. What do we do? Let's find out by examining how we change these crazy exponent expressions into their expanded forms. Let's look at a couple problems. 4 squared times 3 to the third, or 3 cubed. 6 to the fourth plus 5 to the third. 8 squared, or 8 to the second, minus 6 to the seventh. What do we do? Well, looking at it, it kind of seems like we could just sort of take this one and expand it out, and then we could multiply it by whatever this one is expanded out. Let's start with the 4 squared. Well, what does that mean? That means that we got to have 4 as the number we're talking about. How many times is it times itself? Well, 2, because our power is 2. So that's got to be 4 times 4. 1, 2, and our number is 4. We're all good. So now we've got to say, well, I need to multiply this by, so remember, we got 4 times 4. That's just from the 4 squared. And now I'm saying, well, this multiplication, that's got to come in right there. And now I need to multiply it by, well, what do I need to multiply it by? I need to multiply it by, whoop, 3 to the third. So now I'm just doing my 3 times 3 times 3. So my 4 squared goes right here. My multiplication goes in the middle of them, because it's in the middle of them over here. And now I have my 3 to the third just expanded out. And that's actually exactly how you change an exponent expression like this one, 4 squared times 3 cubed, or 4 to the second times 3 to the third, into its expanded form. Let's look at another example. 6 to the fourth plus, not times, plus, not times, 5 to the third. Well, this is really similar, except it has one important difference. Have you figured it out? This one is plus instead of times. So we've still got to take our 6 to the fourth and write it out. So let's run 6 to the fourth over the top. We've got 6 times 6 times 6 times 6. Did I get it? Well, let's see. It's to the fourth. 1, 2, 3, 4. I'm good. Now I need to get my plus in there, so I just drop it off at the end. Add, so 6 times 6 times 6 times 6 plus, what's the next one? Well, it's 5 to the third. 5 times 5 times 5. 1, 2, 3. 3. Excellent. That one comes right under there. The next one I'm going to do, but I'm not going to do those arrows. We're just going to see it kind of visually. So let's say it was 6 to the seventh minus 3 to the fourth. So first we got to do our 6 to the seventh. Well, that's easy. It's going to be 6 times 6 times 6 times 6. 1, 2, 3, 4 times 6 times 6. 1, 2, 3, 4, 5, 6 times 6. 1, 2, 3, 4, 5, 6, 7. 7. Bingo. Minus, and I'm going to switch over here, minus 3 to the fourth. 3 times 3 times 3 times 3. That's a huge one, but the important thing is that we just took 6 to the seventh and we expanded it out. And then we grabbed our subtraction. I am going to do one arrow. I'm just going to say we grabbed our subtraction and it goes right there in the middle of 6 to the seventh and 3 to the fourth. 3 to the fourth. 1, 2, 3, 4. And it's that easy. That's all it takes to take these huge, kind of crazy, got a lot of exponents over here, into just simple, long multiplication problems.